This next chapter, we're going to address elementary particle theory at just the lowest level. This is chapter 42. So we're going to begin with section 42.1 and just kind of get an overview of what particles there are. By elementary particles, of course, as we know, matter is composed, if we have matter, composed of pieces of matter that are indivisible called molecules. And a molecule is a combination of different chemical elements. So we might have something like H2O, which is an oxygen atom with two hydrogens attached to it. Or CO2, which is carbon with two oxygens attached to it. And these molecules are relatively stable, except under extreme temperatures or very high energies, and then they will dissociate. But the molecules are made up of atoms, and as you know, we have a periodic table of approximately 100 elements. These are the building blocks of our all the matter that we are familiar with. It starts with hydrogen, then helium, and as you know, it goes all the way up to uranium, and then even heavier elements have now been discovered. The elements are characterized by unique atoms that have a certain number of protons. Hydrogen has 1 proton, helium has 2, lithium has 3, and so we have protons in a nucleus, proton, say for example in helium, and we may have some neutrons making up that nucleus, and then going around that we have some electrons. We normally have, for a non-ionized atom, we have the same number of electrons as we have protons, and they have exactly the same electrical charge, so that electrical charge balances in its neutral. Now, to go to a deeper level, we certainly know that the electron is an elementary particle, and the proton and the neutron is. So we can ask the question now, what are the protons, neutrons, and electrons made out of? Or are there other elementary particles? Well, it turns out that there are other elementary particles. In addition to these three, there's the photon, which has the characteristics of having no mass and being a component of light. Light is made up of quanta called photons. Gravity is actually made up of a spin 2 particle with no mass called a graviton. This has a spin of 1. These have a spin of 1/2. Planck's constant divided by 2 pi. This is h bar, this is 2h bar. And then we discovered other particles. For example, we discovered a muon, which is very much like an electron, but is different in being much, much heavier. It also has a spin of 1/2 h bar. Then we discovered some particles that interact with the proton and the neutron. The pi, and the pi comes in 3 varieties, positive, negative, and 0. So this list has been growing and growing over the last 100 years and is now quite extensive. We classify particles first according to their spin. If the spin of a particle is going to have 2 characteristics, mass and spin, 2 predominant characteristics, and if the spin is 1/2, 3/2, 5/2, or any half integer times Planck's constant over 2, times Planck's constant, then in fact these are called fermions. If a particle has a spin of 0, 1, 2, 3, and so forth, it's called a boson. Bosons and fermions. So you first have to know that classification. Next, particles are divided into whether or not they're strongly interacting. Do they interact with the nuclear force? Well, it turns out that the proton, the neutron, and the pion do. They're called hadrons. A hadron means it interacts with the strong force. That is the nuclear force. I'll just put nuclear here also. And it's one of the 4 main forces that we have. You'll recall there are 4 such forces. the strong, the electromagnetic force, the weak force, and gravity. And these are the four fundamental forces. These have since been incorporated into one another into what is called now the electroweak force. The hadron is one of these particles, is a particle that interacts with the nuclear force. The proton, the neutron, the pi, these are examples. Proton, neutron, the pion. The pion has a spin of 0. Proton and neutron have a spin of 1/2. Hadrons that are fermions are called baryons. Okay, a hadron can be either one of these, but if it's a fermion also, if it's both a hadron and a fermion, which means it has a half integral spin, like the proton and the neutron, it's called a baryon. That's equal to a hadron fermion. It both has a half integral spin and it engages in the strong force. Examples of the proton and neutron. It's a boson, it's a meson if it's a hadron and a boson. So if it's strongly interacting and has a spin of 0, 1, 2, 3, so for example the pion, which has a spin of 0, is a boson, so it's but it's also interacting with a strong force, so it's a hadron. So we would say that these are baryons and mesons make up the hadrons. Now we have another set of particles that are not hadrons. These are called the leptons. A lepton is a particle that has no strong interaction and is a fermion. So if a particle is a fermion, it has no strong interaction, it's a lepton. If it does have a strong interaction, it's going to be a hadron. A baryon, in fact. Examples of these leptons are the electron, that's the first one. But we've also discovered some other ones. There's the muon, which was discovered in cosmic rays, almost identical to the electron, but just much heavier, about 200 times as heavy. And there's the tau particle, which is even much heavier than that. And these three form kind of a triplet. Then there's another triplet of particles that have no strong interactions, and these are fermions, and those are the neutrinos. The electron neutrino, a muon neutrino, and a tau neutrino. These are particles that have almost no mass. In fact, for a long time it was thought that these particles have no mass. So the mass is very close to 0, so let's say it's very much less than 1, but it's still greater than 0. These are very, very light. These 6 particles make up kind of a group that are very, very important. And there's a lot of parallel between these and the things that we've discovered later about the strong interactions. Okay, so we're going to extend this in the next section and talk a little bit more about the model. We have only discovered 6 of these leptons, and we think that that's all of the leptons that there are. However, for the hadrons, you remember that there are both, for the no strong interactions, they're only fermions. And we'll talk about a couple of other particles that have no strong interactions but are bosons in a little while. The hadrons are made up of the baryons and the mesons. Well, it turns out that the discovery of these just keeps going. There was the proton, the neutron, And after that, you could say, were there other baryons that were discovered? That is, spin 1/2, 3/2, 5/2 strongly interacting particles? Yes. There was the lambda. Then there were 3 sigmas, the sigma naught, the sigma plus, the sigma minus. Then there was the psi particle, psi naught and psi minus. Then there were other particles. There was the omega naught and a whole slew of other particles. And this list went on, and likewise for the meson. There wasn't just the pi, which comes as a pi naught, a pi plus, or a pi minus, 3 different kinds of particles with 3 different charges. There were other particles, the eta, and the k-ion, the k naught, and the k minus, and the k plus. And these k particles were very, very weird particles and had strange behavior. And this list went on and on. So one can say it's certainly not possible that all of these things can be elementary. They must be made up of something just like the elements are made up of electrons, protons, and neutrons. And that's what we're going to discover next in the next section.